the CLM webinar series. We're going to be having a speaker come in, yet to be determined. We're going to be learning about the new publication coming out from the Ohio State University eBarns. This is a research-focused publication that focuses on livestock, forage, and manure management research that's going on around the state. I think we're also going to be trying to get a couple of researchers who are published in this year's eBarns report to come on and talk about their work, just to give you a little bit of a sense of what's going into this annual publication that they're just now starting up. So if you're registered for this event, you should already be registered for that February webinar, but feel free to share this link with anybody that you think might like to join in. We try to make these Go links pretty easy to remember. So if you're ever trying to think of it when you're out there talking to somebody, just remember that go.osu.edu link is what we use for everything. And then it's just /CLM to register for the CLM webinars, or /WQW for the water quality webinars, and that'll get you registered. All right, so today's webinar is going to focus on a few important topics related to organic nutrient management. I'm going to start off talking about the nutrient cycle. I'm going to be focusing specifically on the nitrogen cycle today because for starters, there's a lot going on in the nitrogen cycle, but also we think that focusing on strategies to better utilize the nitrogen in manure as a nutrient source for our crops can be one of the most effective ways to really increase the value of manure applications on the farm. Our speakers today are going to go into a little bit more detail on some of that. But as I said, I'm going to talk about the nitrogen cycle. I'll talk about some of the differences between commercial and organic fertilizers, and then some of the considerations when you're trying to capture the value of manure as fertilizer. Then our water quality extension associate Amber Emmons is going to talk about some of the different manure application strategies and show you some of the technology that's being used today. She will discuss the value of manure as fertilizer and really put some numbers on it to try and emphasize how much money can be saved by effectively utilizing manure as a fertilizer. And then our last speaker today is Mr. Duane Statler. Duane is part of the Blanchard River Demo Farms Network. He's going to talk to us a little bit about what the Demo Farms Network is, as well as some of the work that he's doing on his own farm related to manure application timing. And then finally, at the end, we'll wrap it up with any questions that you all might have for our speakers today. So in order to really capture the value of manure, we really want to try to focus the way we're shifting how we think about manure in terms of shifting our focus from thinking of it in terms of waste management to kind of a more nutrient management perspective. So any livestock operation that's collecting and storing manure, it's going to need to get rid of that waste at some point in time. And the ultimate goal is just going to be to try to figure out how to maximize the value that you can get out of that manure. And there are actually a lot of ways that manure can add value to the farm. The first one being that that can be just a really good source of nutrients for your crops, right? So especially right now when fertilizer prices have been really high, you can really see the value of that manure increase if you know how to use it right. So there's a lot that goes into that. Different types of livestock operations will have manures with, different physical characteristics, different nutrient contents. So it's important to have that manure sampled and analyzed so you know exactly what the nutrient content is. So you can develop an appropriate application strategy to try to maximize the value to that manure application on the farm. So if you missed our last CLM webinar, we had Jason Hartshoe on. He was talking about how and when to sample manure. He gave some really nice examples that really illustrated some of the complexity that can be involved in understanding what the actual nutrient content of that manure is when it's being applied. So if you missed that and you want to go back and check it out, you can find it on our YouTube page. So it's the OSU Agronomic Crops YouTube page. You can go there and just look for the CLM playlist, and that's where we're gonna have all these videos from this webinar series. Another benefit to using manure is that fertilizer on the farm is that those manure amendments to the fertilizer can really significantly impact soil quality by improving the chemical, the physical, and the biological properties of it. So where we see this manure is applied, we can have increased accumulations of soil organic matter. There's increased formation of soil aggregates and also increased nutrient availability to plants. Third point here is that some types of manure may be able to raise or even maintain pHs in soil due to a liming effect. Especially feedlot manure and poultry litter, especially they can have this effect due to the amount of calcium carbonate that's in their feed rations. And then the final point I have on here is that manure applications to the land can increase crop yields. And this is primarily a function of some of these other benefits that we have here. But again, these are just some general ways that manure can add value to the farming operation. If you're already applying manure, then you're already getting some of these benefits. And then for you, the story is going to be trying to figure out how can you maximize those benefits and what other ways can you take advantage of that nutrient source. So those were some of the benefits. There's also a bunch of risks and challenges to dealing with manure on the farm. One of the main things that we're concerned about in terms of nutrient management is phosphorus buildup in the soil. We want to make sure that we're keeping our soil test levels within the maintenance range for the crops that are being grown. They're based on the recommendations of the tri-state fertilizer guidelines. And for corn and soybeans, that upper limit for phosphorus for the critical limit is 40 parts per million. If you're growing wheat or alfalfa, you can get up there a little bit higher to 50 parts per million. But really, research has shown that there's no agronomic value to phosphorus applications when the soil test levels are above that critical level. Furthermore, when the soil test levels do exceed that critical level and phosphorus applications are made, we're really at risk of losing that nutrient source to the watershed. So again, it's just important to make sure that we're testing the manure, testing our soil to see what's out there. That way we can, maximize the value of our fertilizer applications, but also we want to think about reducing the negative environmental impacts as well. There's other risks that go along with dealing with manure, such as potentially metal buildup in the soil, pathogens, spills. These are all things that, need to think about, but really in terms of nutrient management, the big thing is you're trying to keep those phosphorus levels into a good range. On the challenges side, there are a whole bunch of things here that I'm sure everybody can understand: time, weather, cost. All of these things are challenges that you have to overcome in order to successfully use manure in the best way. And nobody's ever going to, get 100% of it or do it, the 100% ideal way. That just won't work out with all of the challenges in the real world. So the only thing we can really do is come up with what our idea might be for what the best plan is for a specific farm. And then we try to get as close to that as we reasonably can. All right, so it's important to work with an agronomist to develop a nutrient managed plan that's going to help you maximize the benefits and then reduce the risks of using manure. Unfortunately, many of the challenges that I have listed here, they're not going anywhere. These are always going to be challenges in farming, and that's why it's important to try to utilize that manure for everything that it's worth. So that brings me to the nitrogen cycle. And as I mentioned earlier, figuring out how to effectively utilize manure nitrogen as a nutrient source for our cash crops is really an effective way to try to increase the value of manure application on the farm. As you can see, this graphic, the nitrogen cycle is fairly complicated. There's a lot of places for that nitrogen to go other than where we want it to go, which is into the plants, right? So I just wanted to go over some of these processes that occur in the nitrogen cycle that transform that nitrogen into different forms, and then talk a little bit about how those different forms of nitrogen might react differently in environments under varying conditions. So Nitrogen is one of the most valuable elements that we can try to utilize from manure. It is the most abundant element in the atmosphere, but it's usually the most efficient element in agricultural production systems. So elemental nitrogen exists in many different forms within the natural environment in all three phases: gas, liquid, and solid. And you can see a bunch of those kind of scattered around this graphic here. Natural processes that occur on the Earth's surface transform that elemental nitrogen from one form into another. I know this graphic has a lot going on, but I want to point out a few things here, starting with these three boxes here. So we have the soil nitrogen pool, the plant nitrogen pool, and the herbivore nitrogen pool. And then between these boxes, you can see arrows connecting each box. And these represent the transfer of nitrogen to the different pools via some type of process. You can see that there's kind of an inner loop that exists here where nitrogen could potentially take a direct path from the animal into the soil to the plant, and that would be the kind of the ideal situation where 100% of that nitrogen is made is recycled in the soil and then made available to our plants, right? Unfortunately, there's a lot more going on in the real world, so I just want to go over some of these processes so you understand what's going on in the environment, and you can make nitrogen management decisions that will allow you to minimize the amounts of loss to some of these potential places. So as I mentioned, atmospheric nitrogen is very abundant. It makes up about 78% of our atmosphere. N2 gas from the atmosphere works its way into the rest of the nitrogen cycle through the process of fixation. So fixation is the conversion of N2 gas to a reactive form of nitrogen by bonding with carbon, hydrogen, or oxygen. And in this case, reactive just means that we're converting that nitrogen into a form that's able to be taken up by the plants. So nitrogen fixation can occur in a few different ways. There's biological fixation, which can be broken down into two groups. So there's symbiotic fixation, which means that there are two different species that are working in conjunction with the other to provide nitrogen and fix it into that plant nitrogen pool. There's also asymbiotic nitrogen fixation, which means that the organisms themselves are able to draw nitrogen out of the atmosphere to use for energy for themselves directly. That's what's going on with the soil microbes in the soil. So the final kind of fixation is industrial fixation, and this is where humans are using industrial processes to extract that nitrogen out of the atmosphere and create things like our nitrogenous fertilizers that we use. So all of the nitrogen in the end cycle enters the system via this process. So that's step one, getting the nitrogen from the atmosphere into that inner loop. All right, so we've got our nitrogen into the plant pool via fixation. Our animals can graze on those plants and take it up into the herbivore nitrogen pool. And then from there, the nitrogen passes on to the rest of the nitrogen cycle through the animal's waste. And we can break this down into essentially two forms of nitrogen. There's organic nitrogen, and this is the nitrogen that's associated with the solid portion of the manure. It's not immediately available to plants, and it has to be broken down by organisms in the soil. This is sometimes referred to as slow N because the process does take some time, and this process is referred to as mineralization. So mineralization is the decomposition of organic nitrogen to ammonium, shown here by the green arrow. The reverse of this process is also possible in some cases. The soil microbes might have a requirement for nitrogen, but there might not be any available in that organic pool. So in these cases, the microbes are able to extract ammonium from that mineral phase to use up. This is a process called immobilization. So immobilization is dependent on soil microbial activity, which is influenced by several environmental factors. So the nitrogen forms in the soil are constantly adjusting to maintain a kind of balance. And ultimately, we would like to have that nitrogen in the soil available to our plants when we need it. So once that nitrogen makes it into the ammonium pool in the soil, we're worried about that, that nitrogen being lost to volatilization. So volatilization is the conversion of ammonia to ammonium gas. This can be lost to the atmosphere. So this is a potential place you could lose some nitrogen depending on how much volatilization occurs. We'll talk a little bit more about what influences volatilization coming up here in a few. But the other forms of nitrogen that we can retrieve from manure is the ammonia portion. And that's associated with the urine. And this is sometimes referred to as fast N. The ammonia nitrogen doesn't require being broken down by organisms in the soil, so it could be available for crops that same year that it's applied. There's no mineralization necessary here. However, once that ammonium is in the soil, it's also at risk of volatilization back to the atmosphere, the same as the ammonium that was mineralized from the organic portion. So once that ammonium is in the soil, we want to keep it here, right? It has the chemical formula NH4 that we can see down here, and we really just want to keep this into the soil until our plants are able to take it up. Now there's some other relationships that you can see here on this graphic that I'm not going to get too much into because the effects are generally pretty small, but you can see ammonia gas can be deposited back into the soil, and some of that is converted into ammonium that can be cycled through. The plants can actually take up those ammonium ions as NH3 or NH4, but this happens in relatively small proportions. Generally, ammonia gas, we end up losing that to the atmosphere, and the majority of the nitrogen that the plants prefer to take up is in that nitrite form. All right, so we've got our nitrogen into the system through nitrogen fixation. Our livestock are able to graze on that vegetation and take it up into that herbivore pool. And then they subsequently provide the soil organisms with that valuable form of organic nutrients so they can do their job. And the organic nitrogen has been mineralized, so the microbes provide that ammonium to the ammonium pool. Some of the ammonium is also available from that urine portion of the excrement, and now we want to get all of that nitrogen into our plant pool, right? So the plants prefer most of that nitrogen in the nitrite form. And it just so happens that nature provides a mechanism for converting ammonium to nitrite. And again, here we can give all the credit to the microbes in the soil for driving the process known as nitrification. So nitrification is the process by which microorganisms convert ammonia to nitrate for energy. So now we have that nitrate in the soil. It's available to be taken up by the plants. Hopefully, the crops in the field are at a good stage at this point to take advantage of the nitrogen that's available. If they're not, the nitrate in the soil is susceptible to loss. Nitrate and nitrite molecules are both negatively charged, and soils are also, they have a negative charge to them. So it's difficult to get that nitrite and that nitrate molecule to stay in the soil, and there are a few ways that we can lose them here. So if the plants don't take it up, soil nitrate could be lost to denitrification. Denitrification is the conversion of nitrate to a gaseous form of nitrogen, which can be lost to the atmosphere. You can see here on the graph that denitrification is actually a source of nitrogen dioxide, or N2O, which is a potent greenhouse gas. That's about 300 times stronger than carbon dioxide. We could also potentially lose nitrate to the process of leaching. Leaching is the process of nutrient removal from the soil by percolation of rainwater, driving that nitrate down into the ground where the plants can't access it. Nitrate can also be lost via runoff, which is technically a little bit different than leaching, but this is still the loss of nitrogen with water. So if we can get that nitrogen in the right place at the right time, where the crops can access that nitrogen before it's lost to the environment, nitrogen can finally be taken up by the crops, which is where we want it to go. All right, and so that will complete the nitrogen cycle. Again, this, what I have highlighted here in red is kind of the ideal situation, just to try to keep all of that nitrogen in the inner circle there, transferring it around between the three pools. We know that that's really unrealistic, so we need to identify some places where we can minimize the loss of that nitrogen via some of these processes that I just went over. So those processes are volatilization, denitrification, leaching, runoff, and immobilization. All right, so how can we reduce the risk of nitrogen loss to volatilization? Well, ammonium nitrogen, or NH4, is more likely to volatilize when it's exposed to the atmosphere and when the temperatures are warm. So the best way to reduce the risk of nitrogen volatilization is to incorporate the manure when the air temperatures are cool. If the manure is surface applied, rain shortly after the application can actually help move those ammonium ions down into the soil to help reduce that loss of volatilization. So getting the nitrogen down into the ground where it has less contact with the atmosphere is important. The table I have here shows how much ammonium nitrogen was lost by applying manure in a few different conditions. Here, manure applied to the land with no incorporation has the highest amount of loss. If manure is applied in a standing crop, you can see here that that pretty much cuts the nitrogen losses in half for all of these different situations. We can also see that when manure is incorporated, there is less loss for the sooner that it gets incorporated. We see less loss. And in terms of temperature, we can see that nitrogen losses are lower when manure is applied in cool conditions. Right? And then the final thing to look at on here is in terms of wetness, we can see that in this situation, there's less nitrogen loss when the manure is applied to the wet soils. So this doesn't mean, you know, saturated soils, because applying manure to saturated soils is just going to lead to runoff. But we did talk about how a little bit of that moisture can help move that ammonium down into the soil to prevent volatilization. So you just need to be careful that it's not too wet when you go to do that. So what about denitrification? Well, denitrification is the process driven by microbial activity. Ultimately, we want the ammonium in the soil to go through that denitrification process so it can be available to the plants. However, if that happens before the crops are ready to utilize that nitrogen source, the nitrate is susceptible to loss. The microorganisms in the soil that drive that denitrification process are much more active once the temperature is warm. So once we're above about 40 degrees Fahrenheit, this process really starts picking up. And as temperatures rise even more, that amount of denitrification just increases. We also risk the loss of nitrate from leaching and runoff if the nitrification of ammonium happens too early. So if that conversion process occurs before the crops can capture the nitrate, we can lose it to leaching and runoff. Again, this is a function of having those negatively charged molecules in the soil that are highly mobile. You can look at the forms of the molecules up there for ammonium and nitrate, and you can notice how the ammonium ion has that positive charge. So that makes it much easier for the ammonium ions to bond with negatively charged particles in the soil, and they stay there a little bit better. In contrast, those nitrate ions have a negative charge, and those are basically like putting two negative charged magnets together. They don't want to stay where they're supposed to, and they tend to just kind of move out of the soil really fast. And the last process on my list here is immobilization. Again, this is when those soil microbes need nitrogen to survive and they don't have any of that in the organic pool to use up. So they end up scavenging nitrogen from the mineral pool. One of the biggest causes of nitrogen immobilization is having a carbon to nitrogen ratio that's too high. Decomposing organic matter contains really low amounts of nitrogen in it. And having high amounts of residue left in the field after a crop harvest, for example, can really tie up nitrogen until that surface residue breaks down. So dealing with surface residue is a big reason that a lot of people do fall tillage. Tillage helps break up that residue physically by breaking down some of that organic matter. And it also allows more atmospheric nitrogen into the soil to feed those microbes so they can effectively break down that residue and they're not trying to scavenge that mineral nitrogen from the soil. So that covers some of the considerations that you should think about when you're trying to avoid nitrogen losses via some of these processes. You're never going to be able to capture all of the nitrogen, but lost my spot here. I'm sorry, you'll never be able to capture all of that nitrogen, but when you take all of this stuff into context, you can start to come up with a little bit of a game plan about what you might want to do to best utilize that manure to get the most value out of it as you can. All of these processes that we talked about today are driven by different kinds of environmental factors. So if you think back to the slide that I had earlier that talked about some of the challenges that you have to successfully utilize the nitrogen in manure, a lot of this comes down to the timing. And, when should that manure be applied? Do you have enough time to get out there in the field before it rains? Can you get that manure out there in time to meet the nitrogen needs of the crop? Will it stay cool long enough to prevent that ammonia volatilization? So a lot of things, focusing on kind of that timing aspect of it here. So you can also try to think about 4 Rs when you're making your nutrient management plan here. If you have manure, you've got the right source that you're going to use. So that one's check mark. We talked about how important it is to test that manure so you can apply the right rate. So we got a green check mark there. And then thinking about some of these environmental conditions that I just discussed, you can see why it's important to place that fertilizer in the ground. All right, so you can avoid some of that ammonia volatilization. So in the ground is the right place if you can do that. And the right time is tricky, to get that right. But hopefully what I went over today helps you think about what you should focus on to try to start venturing down that road to get your nutrients applied, hitting all of those 4 Rs. All right, so this is my last slide I have here. I just wanted to point out some of the main differences between commercial fertilizer and organic fertilizer. So first of all, the total nitrogen that's available from manure contains about 50-50 blend of organic nitrogen and ammonium. The proportions of nutrients in manure that are being applied on the land, they can vary dramatically depending on the type of operation and the method and the timing of the application, right? So with manure, you kind of have what you have and you got to figure out how to make it work well for you. With commercial fertilizers, you have a lot more options with the types of nitrogen that you can purchase. You can make custom blends with it that have just the right amount of ammonium and nitrate available to do just what you want. So that's a big difference. Another difference is that manure doesn't contain any nitrate. So you're really dependent on the soil microbes to convert that ammonium into a form that your crops want to use. And that takes a little bit of planning and kind of a little bit of guessing at what the weather is going to be like and just a little bit of hoping that you can get that timing right there. But manure amendments build soil health up by adding organic matter and building soil tilth. Commercial fertilizers, on the other hand, don't have any kind of increased soil health benefits. They don't add organic matter or nothing like that. So that's a big difference. And then finally, one of the last things on here, manure contains pathogens and bacteria from fecal chloroform, whereas commercial fertilizers do not. So that's a big one that I think people, are aware of. So those are some of the big differences between manure and commercial fertilizer. That's all I've got for you today. So I'm going to wrap it up here and pass it off to our next speaker, Amber Emmons, who's going to talk about manure application strategies and the value of manure as fertilizer. Thank you. All right, Amber, you can take it away.
Yep, just sharing my screen here. I'm trying to present. Okay, can you guys see the presentation, or are you seeing the presenter view? It's still in like the PowerPoint view. How about now?
Nothing has changed for me. Are you sharing your screen, or it's just your screen kind of frozen on PowerPoint view for me? I see your mouse moving.
I'm working. Yeah, let me try it one more time. How about now? Good. Okay,
Good.
thank you. Okay, like Matt introduced, my name is Amber Emmons. I'm also a water quality extension associate like he is, whereas I work in Wood, Henry, and Ottawa counties. And today my talk is going to be a little bit on manure application strategies, how to apply it. Kind of depends on what your end goal is and what kind of manure you have and what its value is. How can you kind of, in a sense, put a dollar to your manure value? So I'm going to break my talk into two different sections. First half of my talk is strictly going to be on the manure application strategies. The second half of my talk, I will go into the economic value of manure, and from there, we'll move on to the next speaker. So one of the first ways you can apply manure is using a drag hose in season. There are different benefits to this. You can do it in season while you have a growing crop in the ground. In this picture, you can see there's about V2, V3 stage corn in the ground, and you're doing minimal damage. You're going to be able to get a crop out of that, and you're able to use your manure later into your season by that. There is some setbacks. It has to be liquid manure to go through the hose, but it is going to supply your corn with its necessary nitrogen for the in-season growing crop. Here's just a short video of this in progress. This is on a field in Defiance County, if it'll play. There we go. So this is how the drag hose works. It's laid out on a 45-degree. Corn is planted on a 45-degree as well if you want it to do the most minimal damage. Run smoothly across the field. There you go. Another way to apply in season, still kind of using that drag hose mentality, is the Cadman continuous manure applicator. Whereas instead of having your corn planted on a 45-degree angle and running that hose down the 45 in the middle of your field, you are able to go back and forth, continuous passes across the field with the hose following you. As you can see on the right-hand side of that applicator bar, the hose is being drug out there. It reels back in as the tractor drives back. As the tractor would come towards us, the reel would wind out the hose and it would follow it. Just another way you can apply in season. And this toolbar does allow you to go a little bit farther, whereas the regular drag hose in that first one, you want to apply up to about V4, then you're going to start doing some damage as the corn will snap at that point. Using a Cadman, you can get up to about V6. Another way to apply manure, this time it's still liquid manure, is using some kind of tanker incorporation, whether your knife, sweep, kind of coulter or disc. It's a little bit more timings of application. You can sometimes apply in season, you can apply out of season in the fall or the spring, but you're just having a lot more weight on your field when you're driving through because all of that manure is constantly in the tank with you versus a drag hose. Most of it is being kept off-site or you're being constantly pumped in. Again, we're using a tanker, but this time using broadcast. It's still liquid manure going through that tanker, but you're splattering it on the ground. And here's a short video of this. The only difference is you're not going to get it incorporated into your field. It's going to lay on top of that field. And later you can go back in and incorporate it yourself with some kind of tillage. But if you're going to do in season, you're kind of limited on your approaches beyond just splattering. Also, depending on your nutrient content, your NP and K in the crop, or even micronutrients, depending how big your corn gets, you can kind of burn the corn when you splatter it right on there when it's young. Another way you can apply in season, this is actually in wheat. This wheat was actually being used as wheatledge. It's still liquid manure, but it's applying right on top of the soil surface, similar to splattering, but you're controlling where it's going. You're using drop nozzles on an applicator bar. You're going to be controlling exactly where it goes on the soil surface, whereas splatter is all over. But again, it's still not being incorporated into the ground with this method. Lastly, this is one way you can apply solid manure, is manure spreaders. Again, this is a broadcast application. It's not really precise of where it's going to go, but you're not having to have all the equipment you need to sometimes use drag hoses, Cadmans, or even drop nozzles. It's a little bit simpler. You just need the trailer, you fill it up. But again, you go back to that, you're going to have more weight on your field when you apply. So some conclusions of just the application strategies, the different applications are going to require different equipment. So whatever your operation has can kind of dictate what or how you're going to apply. And then it also depends, are you willing to spend the money on these different application strategies to try something new? That's up to each farmer and his operation. Then there are a lot of different options, and there are some that I didn't even explain today, but these are some of the more popular ones. And how you can apply can also depend on what kind of manure you have, whether it's dairy, swine, or beef, it's liquid or solid, can kind of manipulate how you're going to apply it as well. Now switching over to manure value as a fertilizer. This is going to be some examples of how I can put a dollar value to your manure. These are examples using prices from NP and K throughout this year. They may not be accurate for your area. You would also may not be accurate for what today's value is. These are what I'm going to use for an estimate. You could plug in your own numbers for your area and for whatever fertilizer you're going to use to try and get your own estimate. But these are just examples. So figuring out a nitrogen cost, and again, this is just an example using numbers from the summer. If you're going to apply 28% UAN to your field as Sidedress or at any other time, the example cost is $589 per pound. There's roughly 3 pounds of nitrogen per gallon. So, and there's 10.6 pounds in a gallon. If we're trying to figure out how many gallons are in a ton, then we use the 2,000 pounds, which is the 2,000 pounds are in 1 ton, divide it by that 10.6 pounds in a gallon. That's going to give you 189 gallons per ton. So in that 189 gallons, how much nitrogen is there? We know there's 3 pounds of nitrogen per gallon. So we take the 3 times the 189 gallons. It's going to give you 568 pounds of nitrogen per ton, approximately. So then trying to put a dollar value to this, you look at the $589 per ton divided by the 568 pounds of nitrogen, you're looking about $1.04 per pound of nitrogen. And again, this may not be relevant to today. This is just an example. Moving on to phosphorus. Phosphorus, our example fertilizer is MAP in this situation. Again, you could use something different. MAP is 11.52.0. The fertilizer cost at the time was $895 per ton. Again, 2,000 pounds in a ton times the 52% or 52 hundredths of phosphorus in it. That's going to give us 1,040 pounds of P2O5. We're looking at it in the version of P2O5 because that's how it's going to be reported to you when you buy fertilizer. So lastly, then it's $895 per pound or per ton divided by the 1,040 pounds. Their phosphorus in this example was 86 cents per pound. Lastly, figuring out the potash. Potash is 0.060, $780, $85 per pound in this example. The 2,000 pounds per ton times the 60% or 60 hundredths gives you about 1,200 pounds of K2O. Again, we're using K2O because that's how it'd be reported to you when you're buying fertilizer. The $785 per ton divided by the 1,200 pounds, that's going to give you about 65 cents per pound. So using all three of these values, you could kind of figure out how many acres you have to apply, how much I'm going to apply, what approximately that's going to cost you. And this is not even considering what it costs you to get that to your field and apply it in fuel. So this is going to be, right now, at least with some of these numbers, it's quite expensive. Whereas if you can try and figure this out, your manure, if you are a livestock farmer, is something you already have on hand. You're not paying someone else for that manure because it's a byproduct that you have. You're still going to pay to have it hauled to the field and applied in some sort of fuel or equipment value, but you're not paying for it, the actual source of the nutrients. Just something to think about if you're trying to put a dollar value to what your manure is. These are just some examples of manure samples. This is what we're going to use going forward to try and get an idea of what that manure is worth. This is a swine example. I have a dairy example coming up. And again, this is an example. Depending on what your manure test values are, it'll be different. It also depends on what you feed your animals. And again, whether it's dairy, beef, or swine. So what we're most interested in is usually looking at the nitrogen, phosphorus, and potassium. The red area indicates it's per 1,000 pounds, 1,000 pounds per 1,000 gallons, I'm sorry. There's a total nitrogen value, which is a black arrow. We're looking at, though, that ammonium value, the 35.97. And then we're also going to look at the phosphorus and potassium, but we're going to look at them as the P2O5 and K2O because that's the values you'd see again when you purchase fertilizer. That's the 12.36 pounds of P2O5, and that's the 29.87 for potassium. So running through this example, the 35.97 pounds of N, pulling back that number from earlier, the $1.04. So in this example, the nitrogen value in your manure is $37.41 per 1,000 gallons. Your phosphorus value per that 1,000 gallons, you have 12.36 pounds of P2O5 in your manure. That's going to be about $10.63. That's kind of per 1,000 gallons what your phosphorus is worth. Lastly, looking at your K2O5, you had 29.87 pounds of K2O in this example at 65 cents. That's $19.42. Altogether, you're looking about $67.46 per 1,000 gallons. Just per 1 gallon, about 6.7 cents. Again, this is just considering the N, P, and K. If you look into manure, like Matt said, there are many micronutrients in there. Whether you look at sulfur or anything else, you could put values to that as well, which would just add to what your manure is worth. Here's a dairy example. Again, we're looking at per 1,000 gallons. So the same basis. Once again, we're going to be looking at the ammonium. So that's the 5.69. You can see it's a lot less in this example. You can also see that the phosphorus, we're going to look at the P2O5 again. So you're looking at about 5.77. And lastly, the potassium is K2O. You're getting about 18.07. This sample comes from an outdoor manure pit that would have rainfall coming into it as well. So we're going to take these values now and do the same thing what I did with the swine manure. So looking at your cost per 1,000 gallons for this dairy manure example, you're going to have 11.38 pounds of nitrogen using that $1.04 per pound of nitrogen, per gallon of nitrogen again. Your nitrogen is going to be valued at about $11.83 per 1,000 gallons. Your P2O5, you have 5.7 pounds of it, 7 pounds of it. So overall per 1,000 gallons, you're going to have $4.96 in your P2O5. As for your K2O value, you have 18.07 pounds of it. So that's going to equal out to about $11.75 for K2O. Overall, then for this dairy manure example, we're looking at about $28.54 per 1,000 gallons, 2.8 cents per 1 gallon. And again, I'm not considering any micronutrient values that could be added in if you add those to your crop. If those are something you regularly buy, that could be figured out as well individually. I am just looking at your NP and K values. So your swine manure had higher values, therefore it was worth more in this example. But both you can place an economic value to determine what is that worth to me as a fertilizer? How much would that cost for the amount of N, P, and K in it? This is some data from Glenn Arnold. I worked with him previously to be my role here as an intern and helped with some of this plot research. He, over 5 years, looked at applying manure prior to the growing crop emerging or after the growing crop had emerged. That's your pre-emergent treatments and post-emergent treatments. And he had 5 different treatments, 6 in the post-emergent. As you can see, comparing always back to the 28%, if we look at incorporated swine manure or incorporated dairy manure, we had a yield bump. We had 15.6 bushels better for the incorporated swine, 15 or just over 16 for the incorporated dairy manure. Whenever we incorporate the manure, we had higher values. Whereas if you see the surface applied swine manure and the surface applied dairy manure, the yield decreased. Statistically, it's about the same, but when we get that manure incorporated in the ground where it can start to decompose, or not decompose, break down using micronutrients or microorganisms, that's when we see the yield bumps. That's when we see a better use of the manure. The post-emergent treatments means this is being applied while there is a growing crop out there. Kind of like my first examples with the drag hose. There is a corn crop or something out there actively growing, sprouted out of the ground, emerged. Comparing back to the 28% UAN treatments again, the 28% had a yield of 144.8 bushels. The incorporated swine manure and the incorporated dairy manure both resulted in yield increases over 18 bushels per acre. The surface applied swine manure and the surface applied dairy manure, both statistically were about significantly the same, not much difference. They were less, but statistically they were about the same. And then you just see there always is a 0 check there where no nitrogen was applied to be compared back to see what kind of bump the fertilizer gives you versus what kind of bump incorporated or surface applied manure gives you compared to no nitrogen at all. This is some data from us water quality associates this year. We did some comparisons of applying manure and incorporating it as your sidedress material versus using some kind of commercial fertilizer. And this was all across Northwest Ohio. There was over 10 fields in this study. And we have most of the yields back. This is preliminary because I don't know that we have all of them back, but so far this was our average. So on average, the manure plots had about 204 bushels per acre, whereas our control plots, again, the control is the commercial fertilizer, we had about 182 bushels per acre. So that's quite a bit of difference for at least this year. This is going to be something we repeat next year. So take it with a grain of salt because this is just 1 year of data, but this year it looked pretty good. So some conclusions for all of my talk. Manure can be a less expensive option for NP and K, along with if you calculate the other micronutrients it gives you, because it is something you already have as a byproduct. You're not paying someone else for that product because you've already gotten it from whatever livestock you have. The pre-incorporated manure treatments in the small plot research resulted in significantly higher yields, while the surface applied ones that were not incorporated had lower yields, not quite significant. The post-emergent manure treatments in the small plot research again resulted in higher yields. Anytime you can incorporate that manure, that's better. And the manure as a sidedress material and on-farm research for the 2022 growing season resulted in about a 20 bushel per acre yield increase. So I want to say thank you for listening to my talk. There's my information, email, phone number. And if you would be so kind to use that QR code and fill out a survey about my talk, I would greatly appreciate it. I will keep that up here just for a second. And then I'm going to hand it off to Duane Statler to talk about his farm.
All right, Duane, are you with us today?
Yes, I am.
All right, great. I got your slide up here. You can go ahead and take it away.
All right. Well, thank you everyone for joining and allowing me to give you a little bit of information. Like you see here, we're part of our farm was selected as one of the 3 for the Blanchard River Demonstration Farm Network. That was put together in 2016, especially looking at the water quality and how we can better improve, or what we're doing is maybe not as harmful as what people thought it is, as far as in the work towards water quality and to what happened in Toledo in 2014 with the shutoff of the water in Toledo. This is primarily in the Blanchard River, is part of the Maumee watershed, which is the Western Lake Erie Basin, which pretty much covers most of northwestern Ohio and gets down into some of Auglaize and Mercer County as the low points that where it stops between there and going towards the Ohio River. It was a partnership, a collaboration of Ohio Farm Bureau, USDA, ARS, and NRCS. It was provided funding to start this project from USDA, NRCS, and Ohio State University has very much been a cooperator in this process since the inception of it. Basically, we looked throughout all of our farm, and we were able to locate 2 areas for edge of field testing equipment. Excuse me. The edge of field testing equipment, we monitor a tile, an area of a field that has got subsurface tile that matches the surface runoff to where we could collect that into a WE. And so we have 2, what we call a paired site, where we have approximately 24 to 30 acres on each site that we are monitoring all the water that leaves through the tile, plus we're monitoring all the water that leaves off the surface. So we're looking to see what we're losing via surface, especially the predominant nutrient is phosphorus, and also through the tile. And that is what it was set up to do. The first 3 years was basically establishing a baseline to where we did not change the practice. We held the same practice. And then after the first 3 years, we've maintained the same practice on the one edge of field site. And then we have changed the practice on the other edge of field site. And you have a lot of questions was raised as far as on what manure looks like, as far as what it does, as far as leaving the soil, how it's attached to the soil. To this day, we have not seen any significant difference in monitoring between the loss of phosphorus from manure as compared to, commercial fertilizers. That has been one of the things that we have looked at, to where if we can, the same thing can happen with manure that can happen with commercial fertilizer, is the ability to leach that we can look at. And so it's just as important for manure to incorporate it the same as what we do commercial fertilizers, in order to not have the opportunity to lose that risk of either as far as on the nitrogen product, the denitrification in the atmosphere, or as the phosphorus to where it can run off on the surface. Because one thing that we can demonstrate that has been an eye opener to me as we look back at all the information we're able to collect, I will refer back to 2017 because it has the best framework of when I've seen that information. In 2017, we happened to have, I think, 10 or 11 major rainfall events that year. And a major rainfall event is what we classify as more than 2 inches in a 24-hour period of time. And in those events, we have the standard practice where we have water control structures that we are using to try to, we've always used those to shut off for our manure application as an insurance policy for anything getting away from us. But we have tried with the use of the demonstration farms, we were trying to use them to regulate the water back. So we would normally shut everything down after we were done with fall tillage or fall application, or the crop was taken off. Normally sometime the second week of November, those water structures were closed, and then they remained closed through the winter. And then we opened them up sometime around the 1st of April to let everything drain to get ready for spring planting. And then depending upon the crop, after we were done, i.e. side dressing corn for, or side dressing nitrogen for corn, or our last spray application of anything we were doing with beans, we would then close the water structures again and not reopen them until about the Labor Day, until we were ready to start drying things off for the field. One of the things we thought we would see was a big difference of how much we were able to retain back through the tile. It was sort of thought through preliminary, as you would do modeling, that we could maybe look at maybe 15 to 20%. In reality, compared to all the years that we've done so far, that has been a practice that is yielding about the 8 to 10% mark, which is not as good as what we thought it would be, but it is definitely a help. But as I was suggesting, is in the large rainfall events, the loss off a surface in a major rainfall event here, there was a time, the last part of June, first week of July, where we received 2 major rain events within a 7-day period. And we lost the equivalent of 3 pounds of phosphorus off the surface during those rain events. Now that's particulate that is leaving through soil, through the amount of corn stalks or bean stubble or organic matter that we have left on top of the soil that is collected, from. But when we're at a goal to where we're trying to remove 1 pound of phosphorus per year, that has a tendency to be an eye opener that there was 3 years worth of what we're trying to save that left in a matter of a week's time. And so that's why it's important that we try to do what we can as far as incorporation to get this stuff done. As far as on the manure, on using it as a nitrogen or fertilizer for any time, we've been working with Glenn Arnold and his project since about 2008, and different areas before we were part of the Blanchard River Demonstration Farm project. We have done everything from, trying to enhance fall applied with cover crops to spring applied to going to side dressing. The most value that you can stand to get out of your manure is when you can put it on a growing crop. The problem comes is when you have the amount of manure that most of us have, is trying to get it out there in a timely order. We've always found that we've always been able to take and get about 60 to 80 acres a year in pre-plant, what we call pre-plant, that we've got time there in the spring that we can come in there and we can go through and we can drag line and incorporate the manure along with drag lining, hit it with a light tillage after that project is done, and then be ready to plant in. And we seem to be able to find no problem in getting that accomplished on 60, 80 acres a year. Then when it comes to side dressing, we've been doing more and more of that every year, but for us, as it seems to be, we're getting about the same thing because of the restraints of getting on in the up to V3, V4 stage, that we can't hardly seem to be able to find to get much more than 60 to 80 acres of that accomplished a year. Have not really seen a whole lot of difference of yield between our pre-plant or our side dress. Although I will say that on our pre-plant, we use absolutely no nitrogen in our starter fertilizer when we do that. Where we side dress, we will still put down about 20 pounds of a N in a 2x2x2 to sort of help that plant get going until we get on with the manure. Post application of manure, you really will see a shot in the arm in your corn crop at that. Like I said, the biggest problem of it is the timing and the application of being able to get there, that V1, V3. Matter of fact, what we did in 2021, we had a very extensive, cover crop there. We had good growth on the cover crop, and the corn sort of stretched a little bit to try to get the sunlight. And even though it was only V3, it was probably closer to the height of V4. Now, in our views from the sky of our infrared views, was the first time that we'd ever seen where the drag hose went that was planted at 45, as we typically do for that 45-degree angle, and side dressed at a 45-degree angle with the hose. But there was a Y period there in that where that hose travels back and forth over the corn, and that showed up pretty significantly in the June infrared. Was not as bad in the July infrared, got better in the August infrared, and we were able to notice it in the yield monitor. We did see that was the first time we'd ever seen that in the yield monitor, where we saw a little bit of a influence. However, we averaged on the whole farm or a whole field, we still averaged about 22 bushel that year better than what our 28% was. And that's the highest that we've ever seen as far as a better yield. And that was even with the little bit of damage that we had on probably about 10 to 12% of the field where that occurred. Our normal average that we've seen where we've put the test beside the 28 versus manure is about 15 to 20 bushel. Some of the things to think about as far as I would add to what Amber mentioned there in her costs that she was showing as far as the value of hog manure. We have, I will say before I get into the cost, that we have seen in about 2012, we started using Phytaste in our feed as an additive to try to lower the amount of phosphorus in our pit manure. And that was done because of this thing of, as we look at the amount of phosphorus that we have and to try not to get the buildup. Our phosphorus levels pre-Phytaste, we were normally in that 20 to 22 range of phosphorus, and we were in that 25 range of potassium. Now we started seeing the decrease right away in the first year, but it took us about 4 years to 5 years to where we have gotten down to right now where we normally see about a 14 to 16 pound of phosphorus per 1,000 gallon in our manure. So yes, the Phytaste has done a good job of reducing that amount, and that depending on whether I've got my environmental hat on or whether I've got my farmer hat on, if you were selling this manure, that has a loss of value. But in a normal double wide building, you have about 900,000 gallon of manure. So that can lead to quite a bit of an economic swing. I've seen in the time that we've had our buildings since the early 2000s till now, I've seen the value of the manure in a typical double wide building go from 10,000 to the astronomical numbers that we look at this year. You take in a double wide, you're normally at what we are today, you're going to look at about $11,500 worth of phosphorus in that building. You're going to look at about $14,500 worth of potassium in that building. So when you start looking at that, that's about a $25,000 value just in those two products. And then when you look at nitrogen, if you look at that dollar, if you were to take that $1.04 a pound for us on our average, that is almost $39,000. So that's why it's important that we put this manure for ourselves in the best place we can get our bang for the buck for it. I'm really interested in the Cadman system. It gives us a lot longer window and a lot larger opportunity that maybe we can push that 60 to 80 acres to that 100 to 120 acre element to be able to take the full advantage use of that nitrogen that we have. And that is pretty much a rundown of what I have for you as far as how it has worked. Like I said, we've been doing this quite a while. We do haul manure, and in the case as far as the economics of hauling manure, I don't have that in a slide or anything that I can put up for you. Yes, it is more expensive when you have to truck that manure. What we did for the demonstration farm, that was about 7 miles. So we had to incorporate 8 trucks to be hauling, for that. But the additional cost of that versus the economics of it, we were still cheaper than buying commercial fertilizer. And that was 2 years ago. This will be this next growing season 23. That would be 3 years since we did that. So even though that is there, when you look right down to it and being able to get that nitrogen, the value of that, every dollar value of that nitrogen, it more than pays for the trucking and stuff to what you have to operate. But it does take some pre-planning ahead of time to make things work out right, to get things done. And I can tell you that Glenn Arnold will be more than willing to help with anyone that's interested in looking at that on some of the ups and downs, and the same way with myself, and the pitfalls that you need to look at so that you can make that a successful operation. And with that, I'll close and leave it up to anybody that has any questions.
All right, thanks a lot, Duane. That was really great to hear from you. So like Duane said, we're going to go ahead and take questions now for that anybody might have for any of our speakers. I'm going to go ahead and go here to this next slide I got. This is an evaluation that I'm going to leave up if you guys could go to that link and fill that out and answer a couple questions. That'll help me make sure that I'm doing good programming for you guys all in the future. I'm going to leave that up while we go through the Q&A session here, so you guys can have a chance to work on that. So I'm not sure if I have. It doesn't look like there's anything in the Q&A session. So if there's any participants on the call that have any questions, you can put them in that Q&A box, or I think you should be able to unmute if you have questions and just ask them directly if you want to. I can go ahead and kind of get started here. If question I had, I guess, Duane, when you were talking about some of the work that you're doing on your farm there, I know you said the timing's a really big thing that you come up against when you're trying to get some of this done. Is there anything that any advice you could offer people on how to best manage their time?
Well, the biggest thing on time is making sure that you can get, we use tanker for everything that we have. And so when it comes to drag line, we have to make sure that we have someone available with that drag line and that timing, down. And they work, that's a sort of a time of year where they're not doing a whole lot. So that does, increase the opportunity to get them, and they're always looking for extra work. But in the case there of the last time that we did this on a large field, was we just rain, and we had the day that we did it, we either did it that day or we didn't do it. And that's sort of the timing that you run into, which is where with the use of the CADman that Glenn has got this year that he'll be using, that really lengthens that opportunity and takes that critical timing out of the way a little bit, because you do gain basically almost another week and a half of an opportunity window to apply that manure. And not only that, but then we've never seen a problem with planting on a 45-degree angle, but it would be nice just to be able just to plant normally, because then you could go into a field. If you had to change field because of weather applications, you've got that opportunity that you don't have to be held to a field planted on a 45 in order to make that drag line work.
When you were saying you had that drag line out there, you said you saw a yield decrease. You were applying that manure in the crop, and you think you had a yield decrease where that drag line was sitting down in the crops. Is that what you said? It
Yes,
kind of
when
made
you
that Y.
when you drag line, of course, you go through the center, then as you drag line back and forth, of course, you've got a hose part that stays sort of in a Y pattern with on each side of your main axis. And that year was the first year that we ever saw anything show up in the infrared to where that pattern was. We had a very good cover crop. And so even though the corn was like in the V3 stage, it was a little bit taller, and it was not quite, because it was trying to get sunlight, it was not quite as healthy. And I believe that we saw that. Now, it really showed up as it came back through the year, through the infrared, it kept getting better. But then when we did go through with the yield monitor, we did see about a 15 bushel to 20 bushel hit, probably at about 12% of the field where that actually happened.
Okay, that's something I guess to always think about. Maybe something that could be avoided with that cadmium system a little bit, not having to drag back and forth over the crops as much. So yeah, that is a neat system. I've seen it operate a couple times. Not sure if we had any questions coming or not. Not seeing any in the Q&A or anything, so I'm not sure if any of our other panelists have any questions, or if anybody else does. All right, well, I'm gonna go ahead and switch the screen here to this next slide that I got. So you guys are interested in CCA credits. You can scan that QR code there, and that can get you signed up for the CCA credits for attending this. Excuse me. That'll get you your CCA credits for this attending this program. If you're interested in the CLM credits, I think we have a poll that we're going to launch, and you can add your information in there, and then we'll get you signed up for those CLM credits as well. All right, I'm just going to leave this slide up here, and that's going to conclude everything that we've got for our webinar today. So I want to thank you guys again for everybody that's attended, and please join us for our next one, and check out some of our other programming that we have coming up from OSU Extension this winter. So thanks for joining, and thanks to our speakers who came on today to present.